So today's focus is going to be on the quadratic formula. The word quadratic means that we're dealing with some kind of polynomial that has an x squared in it as its highest exponent. And that means the shape that we're talking about is a parabola. And when you're dealing with parabolas, what that means is, generally speaking, you are dealing with an equation that has something that looks like the following. Y equals ax squared plus bx plus c. And if you're going to be working with that kind of an equation, which is a parabolic equation, usually your parabolas open up or open down, at least in our course, then the quadratic formula is that the solutions to that quadratic equation are your x values, or your zeros, or your roots, or your solutions, are equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And these a's, b's, and c's are coming from your quadratic equation written above in the red. So everywhere you see a b, that was the value that was in front of the x. Everywhere you see an a, that was a value in front of the x squared, most oftentimes a 1. And the c is the number on the end. And if you don't see anything there, then the c would be 0. When we use the quadratic formula, we talk about something called the discriminant. Now the discriminant, when you look at it, has a certain expression, and it's really the stuff under the square root. So it's the stuff under the square root in the quadratic formula. Specifically, it is b squared minus 4 times a times c. This is the discriminant. Now the thing that's kind of important about that is whenever you look at this discriminant, it tells you certain things. So if this discriminant was positive, that means that there are going to be 2 solutions. If it is 0, that means there's 1 solution. And if it's negative, that means there are no solutions. Because you deal with something called imaginary numbers. Or in other words, if the b squared minus 4ac is positive, you'll see it cross the graph, cross the x-axis in 2 spots. If you see that it's 0, you'll see that it touches, the vertex of the parabola touches the x-axis. And what you'll see if the discriminant is negative is that the parabola doesn't ever touch the x-axis. That's what the discriminant tells us. Okay, the next part is talking about the roots, the zeros, the x-intercepts, and the solutions. All of these phrases mean exactly the same thing. This is when you set the quadratic equation equal to 0 and solve. And you will get either 2 answers, 1 answer, or no answers. Or in other words, this is where you cross the x-axis with the parabola. So you take that x squared equation, set it equal to 0, find your answers. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And those are your roots, your zeros, your x-intercepts, or your solutions. All of those phrases mean the same thing. Whenever I'm solving some kind of quadratic equation, which are the ones with the x squared, what I like to write down are the a, b, and c before I even start to help me remember what to do with them. So let's look at number 1 as an example. In number 1, my A is 1, my B is negative 4, and my C is negative 12. So as I do my problem, this reminds me of what's going on when I solve. So then next, I start my solution. I know that my x values that I'm looking for, or in other words, my roots, my solutions, my zeros, my x-intercepts, are going to be equal to the opposite of the b. So the b was negative 4, so its opposite is positive 4, plus or minus the square root of the b squared minus 4 times the a times the c. All of that stuff, all of it, over 2 times the a. So in case you're having difficulty remembering where all these things come from, the a was the 1, that was here and here. The b was the negative 4 here, and this was the opposite of the b. And then the c was negative 12, so here's my c right there. So as I simplify this stuff, what I'm going to do is I'm going to look at all the numbers that I could make look a little bit nicer, I guess. So this is equal to 4 plus or minus the square root of, and then inside I have 16, and negative 4 times 1 is negative 4, times negative 12 is positive 48, and all that's over 2 times 1, which is 2. And if I continue on with this, this would be 4 plus or minus the square root of 16 and 48 is 64. And that's all over 2. And what I'm going to end up doing is I'm actually going to go in number 2, and I'll have to create another slide for us to do number 2 on so I have more room. But as I simplify this even more, I will have 4 plus or minus 8, because that's the square root of 64, all over 2. Now, what you may or may not realize is that's actually talking about 2 different things. Because the plus or minus is saying that I either have 4 plus 8 over 2, or I have 4 minus 8 over 2. That's what this plus or minus stuff right here is doing. So as I finish my solution, I know that 4 plus 8 is 12, divided by 2 is 6. And I know 4 minus 8 is negative 4, divided by 2 is negative 2. These are my solutions, or my roots, or my zeros, or my x-intercepts. These are the answers that I'm looking for when I use the quadratic formula. So in number 2, since I ran out of room, I'm going to go to a blank sheet here. You might have enough room on your sheet, but with this pen I don't really have enough. So in number 2, we start out with x squared minus 8x plus 16 equal to 0. And as I told you a little bit ago, I like to write down my a's, b's, and c's. So my a in this case is 1 again. My b is negative 8. And my c is positive 16. And then I'm going to be using the quadratic formula because we've already talked about factoring and completing the square. So as I use the quadratic formula, I know that my x's will be equal to the opposite of b. Since b was a negative 8, I'm going to start with positive 8, plus or minus the square root of b squared, so that's negative 8 squared, minus 4 times a times c, and all of that square root over 2 times a. So again, if you're looking for things, my a was 1, here it is and here it is. My b was negative 8, we had to take the opposite of that in the beginning, here's my b again. And then my c was 16, and there's my c. And the 2 and the 4 that you see up there are part of the formula. Those aren't things that you plug in. And then the rest of this is just about simplifying. So now as I simplify, I will have 8 plus or minus the square root of, and negative 8 squared is 64. And then negative 4 times 1 is negative 4 times 16 is negative 64. And then on the bottom, 2 times 1 is just 2. And I notice that inside the radical, I get 0. And the square root of 0 is 0. So really this ends up being 8, and then plus or minus 0, which you don't have to take care of. I mean, it's just there, divided by 2, or in other words, 4. So this is my only x solution, and it's because my discriminant, if you remember that word from a while back, my discriminant up here turned out to be 0. And when we have 0 in the discriminant, that means there's only going to be one solution. And you will learn in pre-calculus that that's because you have something called a double root, which means you actually have the number 4 twice, or in other words, the bottom of your parabola is touching the x-axis at 4, the vertex. So now let's go back to number 3 here. Number 3, we have x squared plus 6